So now in this video, we're going to come back to this circuit here. So we have a transistor that's on pretty much fully right there, and a 5 volt, 1 watt LED module there. But we're only working with 4.2 volts right now. To turn the transistor on, we need a current flow from base to emitter, a small base to emitter current flow, to allow a lot more current to flow through from the collector to emitter. So we got, somewhere about 0.146 amps, which is 146 milliamps. And we can go to 5 volts, and that maxed out the current on there. But there you can see, we got a lot more current. 5 volts should, 5.2 even, should probably be safe. It's a little bit high. But in any case, let's go back to 4.2. We're going to kind of imagine we got a lithium ion cell powering this. We could have parallel cells too. They'll have the same voltage. And they'll be able to store a lot more charge. But yeah, my main concern is that when the voltage goes down, that's about when you want to stop using a lithium ion battery. You don't have to at 3 volts, but it's a good stopping point. And there you can see we got about 4 milliamps of current approximately flowing through there. So my solution was to take a resistor, put it from the base to ground. 10K seems to work pretty well right there. That way the current that does kind of leak through here, we got voltage drops, but they do start leaking current at a lower voltage where current still flows. And so now it will go to ground through the resistor right there, instead of going through base to emitter. And there you can see it's not doing a perfect job yet, but a whole lot better. We got 0 milliamps on there, and I'm not going to measure the exact current like I did in the last video. But yeah, it looks like we got still a slight glow on there. If I tick this down a little bit, 2.8. And for some reason, okay, I wasn't on it, that's why. There we go. So yeah, I can see that little glow went away when I did that. So, and the camera's adjusting to light and stuff. But it didn't look perfect, but that's about as good as I can do. So, we do still have a little bit of current leaking through this green LED right there. We could measure that. So that's what we're going to do with the multimeter right here. Why not? So yeah, we'll zoom in. You can see it glowing right there. I'm going to pull the LED out of this spot right there. So long lead the anode is the positive supply. Short lead the cathode was to that, it's called a Schottky dot. So I'm turning this the other way now. I'm putting the short lead the cathode up one spot. So now we have an open circuit. You need an open circuit in order to take measurements. And we'll zoom back, and we're going to go down to the microamp range. There we go. So it takes 1,000 microamps to give you 1 milliamp. 1,000 milliamps for 1 amp. So it takes 1 million microamps for an amp right there. And so if something can last 1 hour with 1 amp, it will last a million hours with 1 microamp. Something to keep in mind. So yeah, I'll put this up there. We got to put the circuit, the current through the meter, I should say. There we go. And we got the alligator clipped to the probe right there. And I got a jumper that I can plug it in. Plug into the board. So I'm going to go to where the Schottky dot is. And you can see our glow is back. And we got about 41 microamps. So we would need 100 times as much current to get 4 milliamps of current. And that is at 2.8. We really want it low at 2.5. That's when you start running into dangers with a lithium ion cell. But there you can see about 20 microamps right there. And if we go to 3 volts, it's about 58 microamps going through there. And we got a little bit of glow. And so there's, some current going through that LED, but not enough to register 1 milliamp on there. So probably less than 2 milliamps total for everything. And so I am going to unplug this quick before I forget. You gotta be very careful. Measuring current. And so we're going to get that off of measuring current right there. If you put more current through the meter than it's set to measure, then you can blow a fuse in there. And I'm going to rewire this, put the LED there, and put it back. So it's got voltage drop, so does that, so does the base to emitter, but they do trickle current at lower voltages, something to keep in mind. So we got a little bit of trickle there at 3 volts, even with that 10K resistor. But now I'm going to quickly go up to 4.2 volts, and we got 0.147 amps. That's 147 milliamps with the resistor, and there you can see it's practically the same when I yank that resistor. So it's not really affecting anything when we have enough supply voltage, but there you can see when the supply voltage is down and we want to try to make sure the transistor is turned off as much as possible, we can put the 10K resistor from base to ground right there. That helps take away voltage enough to stop that base to emitter conduction. So in any case, again, I improved this and I accidentally wrote 2N2222 on there. Don't use that. Use a transistor that can switch well over 200 milliamps of current. Like the 2N2222 can switch about 600 milliamps of current. But otherwise, it's an NPN bipolar junction transistor. And there's better ways to turn off a load at a certain power supply voltage. But this is a simple one and gets you a little familiar with stacking semiconductor drops and stuff like that. So I think it's a good practice circuit. Probably not a practical circuit, but it will do a lot better job protecting a battery if you're using one than just putting the LED module across the battery directly. So that's safe to do, but the battery will discharge faster than if you wire this circuit, whereas the voltage goes down. It mostly cuts off the current, not completely, but mostly compared to the LED module alone. So in any case, that's it. Thanks for watching. Make sure you check out one of the other videos I posted on the screen and check out links down below. They all help out a lot. I'll see you on the next video.